Originally, when they first announced the airplane, all the airlines in the world placed orders and wanted to get one of these airplanes. But by the time it came out, it was so expensive to operate, so expensive to buy, that no one could afford it, and all those orders were canceled. But it was retired finally in 2003. Started flying in 76 and was retired in 2003 because it never earned any money. It was just too expensive to operate. If you wanted to fly from London to New York City in 2003, when the plane, right before the plane was retired, it cost you $12,500 for a ticket. So you can understand why not too many people flew it.
So what makes it fly so fast?
Well, it's streamlined. It's the fuselage is not real big. If you're over 6 feet, you'd be a little uncomfortable standing up in this aircraft. And another key are the very powerful engines, which give it enough power to travel that fast. Another key factor is the swept-back wing. The aircraft we've looked at so far have wings come straight out. You can't fly supersonically with straight wings. You have to have a swept-back wing, because when you go through the sound barrier, you create so much turbulence that it would tear the wings right off a straight wing plane. It's, yeah, you could call it a delta wing, right? If you look at it from above, you can really see the delta.
Does the nose come down during landing?
Yes, the nose comes down because it has. This wing doesn't have enough lift to fly slow. So when you're coming in for a landing, you have to come in at a high angle of attack, and to let the pilot see the ground, the nose actually deflects. And there's a picture here. There it is. See the nose deflecting on the airplane?
Just like a cobra.
Yeah. I always wonder if that's the shape of it. If that's the shape of it in the ear, but
but no, just when it's landing or taking off.
Okay.
Yeah, it's a beautiful airplane. It used to fly in here to Dallas.
Remedial, truly unbelievable. Got demons saluting you, hairline receiving too, cause of what I do to you. Never mind, it's my God, so I just sit back and watch while he moving you. Like Louisiana, boy, you got the boot. Like Superman, out of heaven you flew. And in the past, I followed you to Port Aramis, but now I'm a trendsetter and I'm setting guys' arrangements. So who do you turn to and nobody to blame? You can't picture this cause there is nobody to frame. I worship God's name when the world call me insane. Say that worship was an option, this ain't the Rose Ball game. Man, I got some revelation and I think it is funny, man, certain so. You went from walking on gold, now you going on your stomach, boy, you were so. The way you move is, the way you prove is, the way you do things, it is so stupid. But you are worthless, you got no purpose. Man, Satan's so dumb.
Space shuttle is covered with, has to be protected against the heat, because when it comes back into the atmosphere from space, it's going over 12,000 miles an hour. And you can't land at 12,000 miles an hour, can you? So you got to slow down. And how do you slow down? You use the air to slow you down. And guess what? That generates a tremendous amount of heat. It gets above 1,000 degrees Fahrenheit on the underside of the space shuttle. So it has to be protected. And you couldn't use a solid heat shield because this vehicle is so big that it bends and twists and expands. That would tear a solid heat shield apart. So the NASA engineers came up with the idea of thermal tiles. So what you see here are 30,000 thermal tiles on this space shuttle, and they were all glued in place by hand. These are not the actual space-going thermal tiles. They're cheap replicas. Okay. This is a real rocket engine from the space shuttle.
Rocket engine.
The space shuttle system has 3 parts. And you're looking at the shuttle. And then the other parts, you see two rockets, silver rockets on either side.
Yes, thanks.
On either side, and those are solid fuel rockets. And they burn for 2 minutes to get the space shuttle going. And then in the middle there's a big orange fuel tank. That orange fuel tank holds 500,000 gallons of liquid hydrogen and liquid oxygen that fuels those three big engines. Well, that fuel tank is emptied in 8 minutes. So after 8 minutes, it's jettisoned and it falls through the atmosphere, burns up. The silver rockets, which are jettisoned after 2 minutes, they parachute back into the ocean. They can be reused. But now, remember, 500,000 gallons, 8 minutes. How many seconds in 8 minutes? About 480, about 500. So you're burning 500,000 gallons in less than 500 seconds. That's 1,000 gallons of fuel a second. This is the Transformers airplane, right? The SR-71 Blackbird. It flies 3 times the speed of sound, 2,100 miles an hour. Now, it's hard to realize how fast that is. But this airplane flew from Los Angeles to here at Dulles in 64 minutes. 64 minutes from the West Coast to here. And that involved a refueling in the air. And we'll talk about that. But so that's how fast 2,100 miles an hour is. It's also faster than a .22 rifle bullet. So this plane can outrun a .22 rifle bullet. Amazing, right?
What's the skin made of? The skin, what's it made up of? What metal?
It's made up of titanium.
Ooh.
Because it gets too hot for aluminum. It gets, even this aircraft flying at 85,000 feet gets too hot.
85,000 feet?
85, 17 miles up in the air. And the air's pretty thin up there, but it's flying so fast it still gets very hot. 700 degrees, a little bit too hot for aluminum. So it's made out of titanium. It's painted black, and the black absorbs radar, so absorbs some of the radar signal. So that helps make a small radar target. But you can see this airplane because when it's flying, the afterburners are always on. So there's flame shooting out of the engines of this airplane at all times. So you can see it. It requires a very special fuel because the fuel circulates all around the fuselage of the aircraft and helps keep the aircraft cool. So it has to be a special fuel called a JP7, which doesn't ignite except at very high temperatures. And the fuel tanks on this aircraft are a problem because the aircraft, when it gets hot, it expands. When it gets cool, it cools down. So all that thermal cycling, they were never able to develop seals for the fuel tanks that could withstand all that thermal cycling. So when it sits on the ground cold, this airplane leaks. It leaks fuel badly enough that you don't fill it up. When you're getting ready to fly this plane, you give it just enough fuel to get it up to a tanker. And a tanker fills it up and it goes on its way. So that's what they did when they flew it here to Dulles. They had to take off and get refueled and go on, and they made the whole trip in 64 minutes.
Now when they fuel it up, it's hot enough for the seals of form?
No, as a matter of fact, no. I've seen pictures of the refueling in the air, and you can see the cloud of fuel vapor coming out of the air. But, you know, from there on it goes very quickly up to altitude and speed.
So even with it getting as hot as it does, it never seals?
When it's hot, it's sealed. It's sealed it's a very efficient airplane. And the engines, of course, have a lot to do with it. They're very special. The engines at speeds below 2 times the speed of sound, they operate like an ordinary turbojet. But when you get up above that speed, it operates as another kind of jet called a ramjet. A And a ramjet's a very efficient engine because it gets a lot of its thrust by compressing incoming air. It doesn't require a big turbine fan, doesn't use a lot of fuel. The only trick with a ramjet is the air at the inlet to the ramjet has to be subsonic. So you've got an aircraft that's going through the air 3 times the speed of sound. How do you slow down the air at the intake to the engine? See these big cones? They recede back into the engine when it gets up to speed, and they restrict the airflow so that as it enters the engine, it's subsonic and it can operate correctly as a ramjet.
Bernoulli's principle.
That's the trick to the speed of this aircraft. Has a crew of 2. Reconnaissance officer sits right here. Pilot sits up here. Those windows are not glass. They're made out of quartz. And the quartz is 4 inches thick in order to withstand the heat load of this airplane. They tell me you can, when this plane's up at speed and altitude, you can fry an egg on the inside of the cockpit against the skin of the airplane.
David, what do you want to say about the engine?
It's amazing.
How does it work? You say the down part and this other part. How is it connected?
How's it connected?
Yeah.
Well, whenever it wants to take off, panels all open up, the exhaust turns down, the lift fan opens up, and it rises like a helicopter. And then whenever it wants to fly, the engine just turns this way, takes off.
How do you know so much about it?
Back,
I have friends that work on it, and I tried to get permission to work on it. And
in the military?
Yes.
Oh, this is a V engine.
That's
12 cylinders, radial engine. Got the accessory compartment in the back.
Yes. Got out and all strips that they want.
We have W-type engine. I wasn't aware of this. W-type engine. They use this for the mill again.
Yeah.
Yeah.
I think they only have one PP.
Then this one is your V-type. V-type. Rolls Royce.
All simplified now.
Now everybody's using horizontally opposed.
Simplified.
Yeah, horizontally opposed. Okay. This one is your inverted V. Okay. This is a jet engine. 8-stage axial flow. This one is your turbo shaft. This one is a 36 cylinder, 4-cylinder roll radial liquid cool.
How many cylinders? 36?
36 cylinders.
Oh.
This is a small turbo jet. Mean your compressor, your combustion chamber, then your turbine, then the accessory section, controlling the propellers.
Why wouldn't you just keep it jet? Like I don't like propellers at
No,
all.
it gives more air. It gives more air.
I don't like propellers at all.
Hey Regina, good to see you. You're out of the Earth Space Museum. How was your experience today?
The experience to me was amazing. I have never flown before, but learning about planes and seeing planes was, was just amazing. And being able to know parts of planes and learning how they fly, it was just amazing. And
now you're ready to take your first flight.
Sure. Oh yeah. No, I'm so eager to fly.
Okay,
so
that's good. That's good. Okay, thank you. Finish our trip from the Air Space Museum. Now we are heading back to the school.